Example 4.6, realistic snowboarding. A snowboarder of mass 72.9 kg and a height of 1.79 meter moves down a slope with an angle of 22° with respect to the horizontal. Suppose the coefficient of kinetic friction between his board and the snow is 0.21 and his velocity, which is along the direction of the slope, is measured as 8.3 meter per second at a given instant. First part of the problem says, assuming a constant slope, what will be the speed of the snowboarder along the direction of slope 100 meter further down the slope? So here we have a snowboarder who is moving down the slope, which can be considered as an inclined plane raised at an angle theta above the horizontal, where theta is 22°. Then the coefficient of kinetic friction mu k between the board and the snow is 0.21 and his initial speed v0 is 8.3 meter per second. We need to find what is his final speed v after he has moved a distance delta x of 100 meter further down the slope. Now, if you have the initial speed and the displacement delta x, and you want to find the final speed v, we use the fifth equation of motion, which says that v final squared equals v initial squared plus 2a delta x. So I can find the final speed v as square root v initial squared plus 2a delta x. I know the initial speed, I know the displacement delta x, but I don't know the value for acceleration a. So first we will find acceleration a and then come back to this equation. So let me call this equation 1. To find the acceleration a, we need to understand the forces acting on the snowboarder. Now the snowboarder is moving down an incline. And for an inclined plane, we know that the x-axis is along the direction of incline or it is along the length of the incline. So we will call this x and the line perpendicular to x-axis will be your y. And again, all vectors to the right will be taken positive and the ones to the left will be taken negative. After we define the axis, we will show the forces acting on the snowboarder. The first force will be the force due to gravity acting vertically down. We call it Fg. Then you have the normal force which acts perpendicular to the surface. We call it N. And then you have the force of kinetic friction. I will call it Fk that goes in a direction opposite to the motion of snowboarder. Now here, the force of friction is along x-axis, whereas the normal force is along y-axis. But the force due to gravity Fg neither lies on the x-axis nor on the y-axis. So I need to split this into components. One component that goes along x-axis, I call it Fgx. And the other component that goes along y-axis, I call it Fgy. Where the component Fgy makes an angle theta with force due to gravity Fg, and this angle theta is the same as the angle of incline. We know that force Fg can be written as m into g. So we can write the x component Fgx as mg sine theta and the y component as mg cosine theta. Because it is the y component that is making an angle theta with Fg, so it is a side adjacent to theta, therefore it will be related to cosine theta, whereas Fgx is away from the angle theta, so it will be associated with sine theta. After we show all the forces acting on the snowboarder, now we are going to write the equation of net force along x and y axis. So let us start with y axis. The snowboarder is not moving along y. There is no acceleration along y. So we write F net along y-axis to be equal to 0. Now there are two forces along y-axis, the normal force and the y component of force due to gravity. And by convention, we take all forces going up to be positive and the one going down to be negative. F net y is the vector sum of these two forces. And when I say vector sum, that means I need to add them by taking their direction into consideration. So I will write the normal force to be positive and FGY as negative. That is equal to 0. So that gives me N to be equal to FGY. And we have found FGY to be equal to mg cosine theta. Let me call this equation 2. Now let's do the same thing along x-axis. Along x-axis, the snowboarder is accelerating in the direction of slope. So we write F net along x-axis to be equal to m into a. F net x is the vector sum of all forces that goes along the x-axis. And when I say vector sum, we add these forces by taking their direction into consideration. All forces to the right will be positive and the ones that goes to the left will be negative. So Fgx here is positive and the force of friction will be negative. Now we know that force of friction Fk can be written as a product of coefficient of friction times the normal force. And here my normal force is mg cosine theta as we found in equation 2. So I can write my force of friction to be equal to mu k mg cosine theta. So we will substitute these in our equation here. Fgx I can write as mg sine theta. Force of friction as mu k mg cosine theta. That is equal to m into a. I can divide by m throughout the equation. So when you divide by m, you get g sine theta minus mu k g cosine theta equals a. So I get my acceleration a to be equal to, take g as common here, sine theta minus mu k cosine theta. Now let us substitute everything to calculate acceleration. I get acceleration a to be equal to 9.81 sine of the angle 22 minus mu k is 0.21 cosine of the angle 22. That gives me the acceleration to be equal to 1.76 meter per second squared. Once I found the acceleration, now I can substitute this in equation 1. In equation 1, we found v to be equal to square root v naught squared plus 2a delta x. Let's substitute square root v naught is 30 squared plus 2, a is 1.76, delta x is 100, so times 100. In part 2 of the problem, they want us to find how long does it take the snowboarder to reach this speed. So I have the initial speed, the final speed, and the acceleration. We can find how long it takes, that means the time t, by using the third equation of motion, which says that v final equals v initial plus a into t. We rearrange this term to write in terms of t. First move v initial to the other side. So you get v minus v initial equals a into t. Now divide by a. T will be equal to v minus v initial over a. Now substitute. V final is 20.5. V initial is 8.3 and acceleration is 1.76. When you solve this, you get the time to be equal to 6.93 seconds. Part 3 of the problem says, given the same coefficient of friction, what would be the angle of slope have to be for the snowboarder to glide with constant velocity? Now, when they say constant velocity, that means the acceleration has to be equal to 0. And we need to find what is the angle theta. So in problem 1, we found the expression for acceleration, which was equal to g sine theta minus mu k cosine theta. And if you want the snowboarder to glide with constant velocity, we have to put this acceleration value to be equal to 0. So let us substitute a as 0. That gives me equal to g sine theta minus mu k cosine theta. I need to solve for angle theta. So let's divide by g on both sides. That gives me 0 equals sine theta minus mu k cosine theta. Move mu k cosine theta to the other side. equals sine theta. Now divide with cosine theta on both sides. Sine theta over cosine theta. That gives me tan theta equals mu k. You can find the angle theta by taking tan inverse of mu k, which is tan inverse of 0.21, which is the coefficient of kinetic friction. So that gives me the angle theta to be equal to 11.86 degree, which you can round off to 12 degree. So this is the angle of slope at which the snowboarder will glide with constant velocity.